appreciate Renee inviting me up here. One of the things I'd like to do is try to inform people what's going on in the world. And here we are in Orange County, as far conservative right-wing Republican as you can get. And as you know, the Republicans are not very keen on global climate change research. They would like to stop it. It's not really the Republicans, it's the people that are behind the scenes. So anyway, I wanted to give you a different perspective. I'd also like you to think about this from another point of view. I'm going to be talking about a world in which you are going to be living, right? Most of you will be married, you'll be at the height of your career, you'll have kids that are going off to college, and so on. This is the kind of world that I'm talking about. I've got 7 grandkids, and I'll tell you, it just makes me sick to see what they're going to be walking into. And why? Because my generation totally copped out. And the generation before, particularly my generation, is doing bad things for the planet. So let's go ahead and start. If you could turn that light down just a little bit. Okay, so the world is warming up. I'll show you a couple of examples. There are endless numbers of examples. And one other thing I want to add. In this talk, no mathematics. If you can handle an XY graph, that's all you really need to know. And I'll allude to the physics, but I won't really say much about physics. So there's no math, there's no physics, just a lot of hopefully pretty pictures, that, a lot of them, that when conglomerated, they'll leave a picture in your mind of where we're going here. Okay, so how do we know the world's warming up? Here's a graph for the last 1,000 years or so of what we think the temperature on the northern hemisphere has been. The little blue line, black line here comes from tree rings. You can see the temperature relative to today is, maybe a few tenths of a degree on the cold side. But here's the thing of interest. Coming in recent times, the tremendous acceleration in the rate at which temperature has increased in the northern hemisphere. But if you're going to do global warming problems, you really want to do the ocean. Of all of the additional heat associated with greenhouse warming that's come into the planet in the last 20 years, 80% of it sits in the ocean. So the key to the planetary climate system is the ocean. Now, Mother Nature has a lot of variability, and that's shown, go back again. I know you can do this. That's shown here with this sort of black fuzzy line. We think Mother Nature has lived in this, within this boundary for a long time, until recently. Starting in 1940 out to about 1970, we begin now to see what has actually happened, how the heat content of the ocean has changed. And I think you'll agree that there's nothing in this range that looks like Mother Nature at all. And it's all happened in about 30 or 40 years. So the oceans, the flywheel of the planetary climate system, are getting warmer. Now, the next bit of talk is structured in 3 portions. One is physics. What are the physical signs of global warming? Then we're going to talk about what the biological signs are. And then finally, what's happening to the chemistry of the planet. And then I'll follow this by the flip of the coin. Okay? People that say there is no global warming, it's all a crock. I'll show you their arguments and some data associated with them. And then we're going to end up talking finally about what the world's going to look like for you. Okay, here's a polar stereographic projection. The North Pole is here. And these colored bands are areas where there is permafrost. The ground's frozen. And in these regions here, it's frozen most all of the year. And you'd say, well, you know, that's way up there. Why do I need to worry about permafrost? Some clever devil, when they put in the Prudhoe Bay oil business, you know, they drive trucks from Fairbanks up there. Well, this guy drilled some boreholes down into the ground, 20 meters down, and put some thermometers in there. And this is what those thermometers have read since the early 1980s. You can see for all of these locations, shown here in a little tiny thing, but basically a line from the Arctic Ocean into the interior of Alaska, the temperature's been going up. 1.5 degrees centigrade is a pretty typical number. Now, what could do that? There are no volcanoes around there. No kind of geothermal forcing would give rise to this. And as I said, in the start, when Prudhoe Bay was opened, they found that they could drive these big, huge rigs from there from Fairbanks out to Prudhoe Bay, and they'd load all their stuff out there. And you've seen, what is it, Ice Road Trucker? You ever seen Ice Road Trucker? That's the crazy guys that do this kind of stuff. Well, here's a plot of the number of days that they could actually make the trip from Fairbanks to Prudhoe Bay and back per year. And about 200 days per year, everything was still frozen. That was cool. Trucks runnable along. But look, when you get out to today, near today, it's down to 100 days a year. So this tells you that that whole area in northern Alaska has more or less solved. That's what happened. The big trucks can't make it anymore. And this pretty picture, it just scares the hell out of me. It's a picture of the tundra. Only what you see in the tundra are all these little ponds of water here. They should be frozen, but the permafrost is melting or has melted, and that gives rise to these ponds of water. Well, guess what's in that water? Methane. As the permafrost melts, it gives off methane. If you date the methane, you'll find that it came from plants that died 40,000 years ago. They've been buried, frozen in place for that period of time. Okay, well, as you thawed out, the methane escapes into the atmosphere. Methane is 22 times more of a greenhouse gas than carbon dioxide. So it's really the bad guy in the crowd. So as we methodically go through and thaw the permafrost all around the northern poles, we're basically releasing more and more greenhouse gases. There's a thing called the runaway greenhouse gas, where the more methane you put in, the hotter the atmosphere gets, the more the permafrost melts, the more methane escapes, and you can see how that's a positive feedback kind of situation. Once that starts, we've lost all control of doing anything about planetary climate. Here's another interesting one, a picture of the Arctic sea ice coverage at the minimum, about September. In 2007, it was this white area that you see here. Let's see, for argument, it's hard to see from that angle. I guess this is Bering Sea or Kamchatka. Anyway, what the minimum ice coverage should be is shown by Sarian Brown. So the sea ice area has shrunk by almost a factor of 2 in this period of time from 1979 to 2007, by a factor of 2. This is important because when the sun's rays come down and hit the ice, it's bright, okay? It's reflected back into space. If there is no sea ice there, as was the case in 2007, that sunlight heat goes right into the ocean, warms the ocean up more. Warm the ocean up means we're going to have less sea ice. Less sea ice, we're going to warm the ocean up some more. So again, this is a positive feedback kind of process. By the way, the things I'm showing you here are not from any climate models or anything. This is just, hey, this is what's happening. Here's one of my favorites. We're sort of working down the spine of the Americas. We started with Alaska and so on, and now we're down, skipping to the tropical zones. This is a Calcaya glacier, and the red area shows in Bolivia, red area shows its circumference in 1940, and you can see in 1982 it shrunk, 2001 it shrunk even more, and today it's basically gone. And this is true of glaciers, almost all glaciers around the world. All of them are melting at a dramatic rate. These faster than the others on top of the Himalayas, for instance, but nonetheless it's happening. Well, how do we know that this hasn't happened before? Well, this is a ski resort that was built at Calcaya Glacier back in the 1940s. In fact, doesn't see much snow there now, do you? The Bolivian army used this whole area to train their Arctic or snow troops, but unfortunately there's no more ice for them to use. So if you want to buy a cheap ski resort, here you go. Going on down South America, this is the most dramatic one, the Patagonian Glacier, the Uppsala Glacier it's called. Here's what it was like in 1928. This is all ice. And notice these peaks back in here. And here's what it was like in 2004. Again, these same peaks. It's just gone. And again, this is repeated round and around the Earth. So the ice part of the Earth is really taking the brunt of the warming. This is, in terms of impact or visual impact, this is an awfully good one. It's a satellite picture of the Larsen B ice shelf, shown here with this blue line. And we'll see it extends back in. within a period of only a month or two, that whole ice shelf collapsed. Here's where it was, and this is all water in there now within a period of a month. And the people that study ice shelves just went off the bridge on this one. I mean, they really didn't know what to do. Nobody expected anything like this. The warming is apparently due to the warming of the ocean underneath. That's warming the bottom of the ice and melting it from the bottom. So if you go from the North Pole all the way down to Antarctica, where this picture is from, you get the same story over and over and over and over again. There are hundreds of examples I could show you that the ice is going away. Why is that happening? It's getting warmer. That's about the only explanation. This is a 800-pound gorilla that we climate people worry about in Greenland. And the orange areas are where Greenland was melting in 1992. And here's the same picture, but now this is what it was melting in 2002. Look how the area is increased. And since then, it's gone on. Here's a time series now. Here's your time running along here, and the total area of the melting of the Greenland. And you can see there's a lot of noise in here, but the trend line shows you that, in fact, the melting's increasing. If you compared this picture with the last one, you'd also find out that more areas encompassed in this. Well, why do we care about Greenland? I mean, again, we don't live in Greenland at all. But if Greenland were to melt, sea level would rise 7 meters. Okay, take your favorite beach in Southern California, it's gone. Miami, gone. New York, gone. Amsterdam, gone. Maldives, gone. A 20-foot rise in sea level would drastically change the economics of the world. When Greenland melts, it melts with these big lakes. So if you look at it from an airplane during the summer season, you'll see the top of it's dotted with these lakes. Most all of the lakes have an escape route or a river that they feed, and that's what this is. This water coming out of one of those lakes and plunging down into a black hole. This is called a moulin, and what happens is this meltwater works its way all the way down to the bottom of the glacier, to where the glacier meets the rock underneath, and it acts like a lubricant. It helps speed the motion of those glaciers or parts of it out to the ocean. So I think, although it's not my favorite subject, but Gore represented this in an interesting way. You can think of the art of Greenland as being a piece of Swiss cheese with all the holes and everything in it that these are creating. Point is, Greenland's on the way out. The good news is it's probably going to take 100 or 200 years for that to happen, or maybe longer. But the uncertainty here is that the Larsen B ice shelf went in a month. There's a lot more ice here, of course, so that's going to take longer. But I think none of us are surprised anymore by how fast things can happen in the climate world. Okay, where's sea level going to end up? Here are a number of different estimates of it. The black line has a rise of 100 centimeters a meter. And these bars out here, as you go out here, they get more and more recent scientific research and shows you that there's a wide uncertainty on what's going to happen. But the state of California now, for instance, is planning on a 4-foot rise in sea level by 2100. All the state agencies have been asked to plan for that. Even a 1 meter rise in sea level is bad news. I'll talk more about this a little bit later on, but let's switch over now to biology. How are the critters going to get along? How are they going to like all of this, or will they just not care? Here's a picture of most of the big coral reefs in the world, shown by these dots. And the red dots are where the coral is badly bleached, where it's died. Blue dots are where it's relatively healthy. Coral is a funny critter. It lives within about 1/2 degree of its temperature maximum, right on the brink. So if the temperature increases 1/2 degree centigrade, coral dies. If temperature decreases by 2 degrees centigrade, coral doesn't care. That's living right at the very edge, and we would think it to be one of the first indicator species. And you can see from the amount of red dots on there that the corals in the world tropics are really in trouble. Here's one for the non-scientists.